the answer? -8 or 8, exactly. So there's first thing you got to know. Typically, when we solve absolute value equations, instead of getting a single solution, we would normally expect to get two solutions. We won't always get two solutions, and we'll see some examples of that happening today. Go ahead and click the Chromebooks all the way closed. I want to get everybody's undivided attention up here. So we get two solutions out of this, right? Either x equals 8 or, and that's my symbol for or, by the way, is a capital V, kind of like a capital V, or x equals -8, because of course the job of an absolute value function is to output a non-negative result. So if it starts out negative, we're going to flip it and make it positive. Starts out positive, we leave it alone. Starts out 0, we leave it alone. Okay? All right, so then let's talk about how we would do one like this. What do we do first? Okay, no, we do not. You cannot distribute the 4. Distributing the 4 will unambiguously give you wrong answers, because the rule is this: you can't treat absolute value bars like parentheses. They're very different, right? Absolute value bars make math tricky. So our rule of thumb is we can never do anything inside the absolute value bars. Okay, step number 1, that's off limits. What we do instead, what's our plan B then, you think? Add 2 and then divide by 4. Good, because what we really want to do here is we want to isolate the absolute value. We can't touch anything inside the absolute value. But goal number 1 is to isolate what's inside. Okay? So if we isolate what's inside, and I'm actually, just so we're not tempted to cheat, I'm even going to cover up what's inside. We'll just call it U. Okay? Right? So you already told me the steps I want to take to isolate the absolute value of U. I'm going to subtract 2 and divide by 4. Okay, good. So I isolated the absolute value. That's part 1. What's part 2? Okay, we can't solve the absolute value equation by itself. We don't want to do that. We want to make a trade here. Remember doing this? So maybe that 5 on remember an absolute value equation, maybe that should have been a little lower than a 5 for some people. What do we do with that? When we isolate the absolute value, you tell me now, once I've got it isolated, what are the values that you could have? +10 or -10. So step 2 is we split the absolute value equation. We're going to trade one difficult absolute value equation for 2 simple regular equations. Right? So we're going to split this so we either get U is equal to -10 or U is equal to +10. Only remember, it's not actually a U, is it? It's not really a U, it's something other than a U. There's something actually back there. Oh, I didn't want to remove the absolute values. That wasn't what I was supposed to do. Where'd they go? Oh yeah, no, I did. What am I saying? I did remove the absolute values. That's the whole point on this step. Right, that's the whole point of this, is that, let me gather up all those U's. Okay, there we go. We can junk all those guys, how about? Because the idea is once we isolate the absolute value, we can trade that single absolute value equation for 2 regular ones. Whatever's inside either has to equal the negative number or the positive number, right? Either equals what the positive number that's outside or its negative opposite. I should say it that way. Okay, you get the idea? Now, what happened there that was awesome in that step? The absolute values are gone. Now we just solve them like regular simple equations. Okay, right? So 3 steps. Step 1, we isolate the absolute value. Step 2, we trade the absolute value equation for 2 regular equations. We could call that splitting, right? That's the splitting step. And then step 3 is so easy, it's just not even almost worth mentioning. We just solve those 2 equations, right? And what the steps are the same. I'm going to get different outcomes, but the algebra steps to isolate the x are the same. I'm going to add 6 and divide by -2 in both cases, right? and I get the answers x equals 2 or x equals -8. Okay, give me thumbs on that. Is that ringing a bell? Okay, I've got one other question for you, because I will get asked this, guaranteed. Because this stuff is inside absolute values, can I get rid of the negatives? I cannot. I cannot. We're stuck with whatever expression is inside, because our job is to figure out the values of x that are going to make that exact expression, that exact equation work, right? Which includes whatever's inside the absolute values. I can't change it. If I were to change it and eliminate those negative signs, I would have gotten different solutions, not the solutions that I wanted, right? Yes, sir. Now, what if there are absolute value signs on both sides of the equation? Okay, if there's on both sides of the equation, we we won't look at one of those today. There is a process for that. Um, it's it's a little more, well, I'm not sure if we'll even look at one. We might, just for you guys might enjoy that, but we're not going to do it today. It's a very good question though. Okay, like what if I had an absolute value? Oh, maybe you mean this. Like what if I had an absolute value around a -36 or something? Okay, well, what is the absolute value of -36? Okay, in that case, I can't do it. If I have just a number, if I have a number inside, no variables, then I can actually simplify the absolute values, right? But when I have a variable inside, I can't do it. I have to leave it alone. Then couldn't I couldn't touch either one of them. Okay. I mean, you guys could actually reason this out. When we're all done, at the end of the day, we'll go back and I'll ask you how you'd approach it. And you can tell me. Because we're going to look at one that'll get you ready for that idea. Okay. All right, moving on. What about this guy? So what are the steps? Subtract 11, divide by 2. Everybody agree? Okay. Subtract 11, divide by 2. $68. Okay, so then divide by 2. And would everybody agree my isolated absolute value is equal to 34? Okay, now what's inside? Well, what's inside hasn't changed. What's inside is a 2x minus 20. So that's part 1 is done. We isolated the absolute value. Check, right? What's step 2? Good. Split it. Perfect. So what's inside? And now here's the other mistake that people sometimes make is they want to make what's inside positive and negative. No, what's inside stays the same. You either get 2x minus 20 equals positive 34, or 2x minus 20 equals negative 34. So step 2, split. Check. Step 3, solve. Okay. Do these in your head. What do we get here? 7. 27. That's 27. Okay. Good. Okay. Agreed? No problem. No problem. No. We can skip this one. What's the one step to isolate the absolute value here? Multiply by 3. Okay, we'll skip that one. You guys don't need that one. Okay, this one I want to look at. It's a little different. This one's a little different. And you guys, we probably don't need the use. You're good without the use. Oh, well, maybe. So what are the 2 steps to isolate the absolute value? Add 11, divide by 2. So that gives me, if I do those 2 steps, I get 2 times the absolute value of 3x plus 6 equals 0. If I divide by 2, I still get 0. That's right. Yeah. So I get the absolute value of 3x plus 6 equals 0. So we isolated the absolute value, but the splitting doesn't make sense here, right? Because think what happens when we split it. We said we'd set up 2 equations. What's inside equals the positive number outside, or what's inside equals its negative opposite. Okay, 0 is 0 positive or negative? Neither. It's signless. 0 is the boundary between negative and positive numbers. So the opposite of 0 is 0. So I only get one equation out of this, don't I? Okay, so this gives me the single equation. 3x plus 6 equals 0. So we get, I only get a single solution that time. Okay, make sense? Okay, how about this guy? Okay, isolate it. First of all, isolate the absolute value. What do I get if I isolate the absolute value? No, I don't think so. So what do you get? Well, but we're just isolating the absolute value now, right? Okay. So when I split it, what do you get when you split it? Mm-mm. Mm. No. I'm going to ask you guys. I'll give you a little hint here. What's the absolute value of negative 3? What's the absolute value of positive 4? What's the absolute value of 0? Okay. Think about those outputs. They're all non-negative, aren't they? No. No. The answer is no solution because it's impossible, right? Okay. The output, you tell me, sometimes, always, or never. The output of an absolute value function is negative. Never. So there's no solution. Yep. If an isolated absolute value is equal to a negative number, the answer has to be no solution. Okay, and I'll show you another justification for that real soon. Okay, give me 1 to 5 on that. Does that make sense? Okay, right. So really, we got to say when we break our steps down, the splitting part would only ever make sense if the isolated absolute value is equal to what? A positive number, right? If it equals 0, there's only one solution. If the isolated absolute value equals a negative number, it's impossible and there are no solutions. Yes. Okay. Okay, so last issue then. Last issue is, what looks harder about this one? Variable on both sides. Okay, variable on both sides. So what do we do in the instance where we have a variable on both sides? The answer is we're going to follow the same strategy we did before, right? So we're going to, in this case, it's already isolated. We didn't have to do anything to isolate it, right? So that part was done for you. Step 2 is the split part. Okay, so whatever's inside. Yeah, or positive. Yeah. Yeah. Okay, so either what's inside equals the positive expression, outside expression, or it equals the opposite, the negative opposite of the outside expression, right? And we would just solve both of those. Okay, so what if we solve this guy? Where am I pushing the x's? I want x's on the right. So how many x's on the right do I end up with? Okay, where am I pushing the constants then? Left. Right? Okay, so what's x then? Okay, so there's one solution, right? Yeah, but we want a positive number of x's. It makes it a little bit easier, right? Okay, now how about over here? If I distribute, I get 14 equals negative 14x minus 4. Pushing the x's left. How many?
Positive 26.
26, because I'm adding 14x, right? So I get 26 x's on the right. What's my constant? How many? What's the number on the left? Sorry, I'm going to get 10. Good. Divide by 26, and I get x equals 10 over 26, which reduces to. Okay, but not as a. Let's do it. A fraction.
1/3. Wait.
That would be 27.
No, I took 2.6. I made it into
5 over 13. There you go. Okay. Done? Done? Agreed?
Yes.
Wrong. We're not done. We're not done because there is a really important rule that you have to follow here. In fact, I'm going to write this down. I'm going to type it so it's nice and neat on the notes. I would encourage you, I mean, if you want to write this in your notebook, go ahead. I will post these notes tonight, though. So if you're okay just using the notes on here, that's okay too. But this is really important. Okay, so important. It's going to be written in red. It's going to be written in red. Okay. When solving an absolute value, as you can see what a bad typist I am, value equation with variables on both sides. Okay, I'm going to make that. Okay, let's make that a little bigger. Oh, that's too big. Okay, so whenever we're solving an absolute value equation that has variables on both sides, we have to check these. What does extraneous mean? Extraneous.
like it's pushing something.
No, extraneous means false. It means false or invalid. Okay. So let's make a note of that. Extraneous is really just a synonym for. Okay, so we've got to check these. Now, where do we always check stuff? If I want to check these solutions to see if they work, where do I go? I have to go to the original absolute value equation. So this is important. You can't go back to the equations after you've done the split, right? You have to go back to the original one. Okay, now we can do this. I showed you how to do this on Desmos, correct? Okay, I'm going to remind you real quick how this works on Desmos. Remember this stuff? Okay, so we're just going to input, just like we always do, we're going to input, make f of x, set that equal to the left side of the equation, g of x equal to the right side. The absolute value button is, the bars are just right there, right? Everybody see that? Okay, so there's my f of x and g of x, right? I'm going to check them both for -9. So f of -9 gives me back positive 122. Okay, what should g of -9 give me? Should give me 122, right? But it doesn't. It gives me negative 122. So you tell me, is -9 a solution? No, it's not, because I got different answers. I got the right. Well, let's do this. Okay, so everybody gets that? Because these are different answers. That's supposed to be an X. That's not a very good X, though, is it?
Oh, it has an X.
This pen is just kind of, it's, I don't know, it's not so great. So x equals -9 is not a solution. Right now, if I go back, I can just use all the stuff I already did and just overwrite the -9 with a negative 5/13. Is that what it was? Positive 5/13. Okay. Okay, so here's. Okay, so if I just overwrite that -9 with a 5/13. Okay, and I'll convert it to fraction. What do I see now? Same answer. What's that tell me? Yes. Okay, so everybody agree. Hey, I need you guys back on track, please. So everybody agree 5/13 works then? That is a solution. It checks out. Okay, so let's try one more of these. When are we out of here? 35? Okay. Do you want to do this on the board, or do you want to just talk me through it? Your call. You want to do them on the boards? Okay, talk me through it. Okay. Okay, so it's already isolated. What are the two equations I'm going to set up?
The absolute value of x minus 4.
No, hold on. The whole point of the split is to get rid of the absolute values, right?
5x plus 12 and x minus 4 equals negative in parentheses 5x.
You don't need the parentheses to be honest. It'll just flat out the same thing.
Yeah, or that's fine. You can do that. Or you could say whatever's inside x minus 4 equals the opposite of what's outside. If I distribute the negative, I get negative 5x minus 12. Okay, let's quickly look at these. So I'm pushing x's right or left? Right. How many do I get?
6.
Okay, 4. So the numbers go to the other side. What do I end up with? What number on the other side?
That's 8. That's negative 16.
Okay, I got lots of answers to that one. So what's my solution? Okay. Okay, or over here I'm pushing the x's left. How many?
Positive 5.
Okay, what's on the other side?
Negative 8.
Negative 6.
Oh, wait, no. You guys. It's simple.
I give up. I'm just plowing ahead. So, okay, so now I want to show you how you can do this on your TI-84s. Okay.
My brother had to take it for college. It's not fair. Same.
So now I'm going to pull up my TI-84. Here's what the 84 CE looks like. Okay, how do you do this on a TI-84? Same kind of thing, only slightly different process. We want to evaluate both sides of the original equation for these two numbers. So the way you do this, we have to first type in the expression that's on the left side. We don't set it equal to anything. We're just going to type it in. So I need to put in the absolute value of x minus 4. Well, how do you find absolute value? There is no absolute value on the front keyboard, looks like. Okay. So where do you find it? It's no place. You can go, no. And you can tell it's not second because when you hit second, you just get the blue functions that are up above, and I don't see any absolute value bars anywhere. Okay, so here's an easy way to do it. I'll show you 3 ways. The kind of the standard way is to go to the math screen. That's where all the math goodies are. So if I go to the math screen, there are 5 menus. There is the math menu, which has a bunch of, like converting to fraction, converting to decimal. I've got xth roots. I've got minimums of functions. I've got numerical derivatives. A lot of this stuff you will never have heard of. Some of it you will, though. We'll use some of that stuff. Okay, we don't want that menu. We want the number menu. We want the menu so we can do something to numbers. We want to take absolute values, right? So we go to the number menu, and it's the first option. So again, that would be, how did we get there? We go math screen, scoot to number menu, and either type a 1 or enter because it's already on the 1, and I get absolute value bars. Okay, that's one method to do it. Another method to do it is you can use and you'll get to know these. You can use the alpha shortcuts. If I hit alpha, there are 4 really quick pop-up menus that I can pull up if I hit alpha F1, alpha F2, alpha F3, or alpha F4. It's alpha F2 is the one that we want, which is the function menu. And look, there's absolute value. I can see I can scoot over. I can get a matrix menu for doing matrix operations. I get a Y variable menu if I want to access the Y variables, or I get a fraction menu if I want to pull up like fraction templates and things like that, which I think we've seen that already too, maybe, huh? But in this case, we want absolute value. So I would just go alpha F2, enter. That's another way to get it. Okay, the third way to get it is actually the quickest, but nobody would ever use this way. I use this way. If we go down to the catalog gives you all the functions on the calculator, but what do you, in alphabetical order, what do you think the first one is? Absolute value. So if I hit second catalog, enter, you get it really quickly. Okay. Okay. So either way, we get any of those 3 ways you want. We get absolute value bars. So we want the absolute value of x, and there's my variable button right to the right of alpha, x minus 4, and I hit enter. Now I've created it. I want to go down to the edit bar and create another one. So I'm going to create the expression on the other side, which is just 5x. So 5x plus 12, and I hit enter. Okay. Now, to use those expressions, I want to plug in a value for x. So I'm going to plug in -4. I'm going to type the number -4. And when you're typing a negative number on the TI-84, you can't use the minus key. That's meant as an operation. You have to use the negative key, which is down at the bottom. So -4, and I want to store that as x. So I go down to the store button, which has a right arrow on it. It's right there. Store as x. I type the x button and hit enter. And now what's it say? It says -4. So that's the value that's stored in x. Now that I've stored that value as x, I'm going to go back up and highlight and grab by hitting enter. I'm going to grab that expression. So I go up and highlight it and hit enter. And I hit enter again to evaluate it. Tells me 8. So when I plug -4 into that, I get 8. Okay. I'm going to go up and grab the other expression just by going up until I get to that expression and hit enter, and then enter again to evaluate it, and look what happens. It's -8, so that's not going to work, right? Okay, so let me take a picture. Yeah. No, paper. That's like last millennium. Well, you should write everything down on paper. You really should. Okay, so there's the TI-84 way of doing it right above the Desmos way. Now let's go back, and all I have, well, you tell me, what do I do to check negative 4/3? Okay, good. So I go negative 4 divided by 3, store x, enter. Now it's gonna write it as a decimal always. That's okay. And then I go up and I grab the left expression and hit enter. So there's the result. I go up and grab the right expression and hit enter, and I get the same thing. Okay, so that's telling me that that is a solution because it worked. Okay, and there it is in your notes. Give me 1 to 5 on that. We good? Okay, I'll put the assignment up. You can work.